This is Geometry Unit 4, Lesson 5 on dilations. A dilation is an enlargement or reduction of a figure. Usually when you hear the word dilation, you think of your eye. The pupil in your eye will get larger or smaller depending on what kind of light you have. So if something is dilated, it can be larger or smaller. Now, when we're doing dilations in geometry, we have what's called a center of dilation. If point P is the center of dilation. If you are doing an enlargement, all points move farther from P by a factor of an integer. Remember, an integer is a positive or negative whole number. So if you are going twice as far, 3 times as far, 5 times as far, negative 2 times as far, you're going to be enlarging it that much farther from P by a factor of an integer. The image will be actually, if it's farther away from the center of dilation, it will be larger than the original. Now for reduction, all points move closer to P, whatever the center of dilation is, by a factor of a fraction. So the image will actually be smaller than the original. So a constant of dilation, sometimes called K, is the factor or ratio by which everything is enlarged or reduced. So each point of the figure is multiplied by K. So a dilation, you multiply by some factor, whether it's a whole number or a fraction. If it's a whole number, positive or negative, then it would be enlarged. If it's a fraction, it will be reduced. Now let's try a problem with dilation. We are going to find triangle A prime, B prime, C prime, which is the dilation of triangle ABC by a factor free from the point P. So each point will be 3 times the distance from P. Three times the distance from P. So if we are looking at the distance from P to A, which would be PA. PA, if we count, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the distance from P to A is 10. So that means the distance from P to A prime will be 10 and then times 3, which will be 30. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So A prime will be here. The distance from P to A multiplied by 3 will be P to A prime. A prime is 3 times the distance away from P. We would do the same thing for each point. PB. The distance from P to B is 1, 2, 3, 4, 5, 6. So P to B prime will be 6 times 3, which will be 18. So this would be 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So B prime will be there. And then PC, PC, not BC. Sorry about that. PC is 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means PC prime will be 9 times 3, which will be 27. So that actually puts that one right here. Trust me if you count it off. All right, C prime will be there. So if I connect my points, A to B, A prime to B prime to C prime, I should create a triangle that is larger by a factor of 3. This triangle is 3 times as long or large as this triangle ABC, and it's also 3 times the distance away from the center of rotation or center of dilation, which is P. So that should be A prime, B prime, C prime. Now let's try the second one. Find triangle A double prime, B double prime, C double prime, which is the dilation of triangle ABC by a factor of 1/2 from the point P. So we're going to use the same point distances. PA is 10, PB is 6, and PC is 9. But this time our dilation factor is 1/2. So that means we take each point and multiply it by 1/2. So PA prime will be 10 times 1/2, which is 5. So 1, 2, 3, 4, 5. This would be A double prime. Now notice the distance from P to A and P to A prime is half the distance as P to A. So PB prime will be 6 times a half, which is 3. So 1, 2, 3. B double prime is there. And then C double prime, PC prime, or PC is 9, so PC prime will be 9 times a half, which is 4.5. So 1, 2, 3, 4 and a half would be right there. There's C double prime. If I connect my points, let me do this one in blue so you can see which one I'm doing. All right, there's my points. Notice that my triangle, because the dilation factor was a half, is half as large as ABC. So A double prime, B double prime, C double prime will be half as large as ABC and also half the distance from P. So with an enlargement with a factor of 3, it will be enlarging, it will be larger by that factor, and that multiply that factor as far from P. And then this one, because it's half, it'll be smaller because it's a fraction, and it'll be closer to P. Now let's look at dilations in the coordinate plane. We have triangle ABC with vertices at A50, B24, and C -1, 2. It's over here. Dilate triangle ABC by a factor of 3 from the origin. Now remember, if it's a factor of 3, it means we're going to multiply each coordinate by 3. So 50 multiplied by 3 will become 15, 0, because if it's from O, the origin, to A is 5, then from O to wherever A prime is going to be 15. And that actually puts it right here. I count over to 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That will be A prime. So that's at 15, 0. So if B is at 2, 4, multiply both coordinates by 3, we end up at 6, 12. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. There's B prime. Now notice that it doesn't look like it's that far away, but if I draw this imaginary line from B to B prime, notice the distance from here to here is 1/3 the distance from here to here. So B prime is 3 times the distance away from B. So that is on the line when you do that. All right, so let's look at C and C prime. -1, 2 multiplied by 3 would be -3, 6. 1, 2, 3, 1, 2, 3, 4, 5, 6. And there is C prime. Now if I connect my points, now this is a factor of 3, so it should be larger. It should be 3 times the size and 3 times the distance away from P. So there's my triangle, and you can see it's 3 times the size and 3 times the distance away from C. Yeah. All right, so from the origin, I should say. So the rule for dilation of a factor of K, so whatever you're multiplying by, you see it as D of K. This is your factor right here. What do you just do with the coordinates? You multiply them. So D of K of XY comes out to be KX, KY. Multiply both coordinates by K, whatever K happens to be, if it's a whole number or if it's a fraction. So if you see D of 4 of -3, 5, this is saying to take 4 and multiply it by X and multiply it by Y. So -3, 5 would be -3 times 4 and then 5 times 4. So that will give you the point -12, 20. Now, what if we had D of 3/4, 8, -12? All right, your dilation factor is going to be 3/4. So that means this would be 8 times 3/4, and then -12 times 3/4. 8 times 3/4 is 6. -12 times 3/4 is -9. Multiply each coordinate by 3/4. And notice this is going to be closer to the center of dilation. All right, now that we know that, find the value of k if d of k is 6, negative 9 becomes 10, negative 15. All right, now remember, to get each of the coordinates, all you had to do was take the first coordinate, multiply it by k, and you get the second coordinate. You get the image. So, if I use the x-coordinate, it would be 6 times k should equal 10. Well, if I solve that for k, I get k is equal to 5/3. Now, it doesn't matter which coordinate you do because it's multiplied by the same coordinate. So if you did it for y, it'd work the same way. Negative 9 times k should give you negative 15. Divide by negative 9. Negative divided by a negative is a positive, and this reduces to be 5/3. Remember, both coordinates are multiplied by the same thing, so if you set it up as a factor, it works. All right, now let's look at a negative integer as your dilation factor. D negative 2, 2, 3. Well, this says your dilation factor is negative 2. So this is going to be 2 times negative 2, and then 3 times negative 2. So 2 times negative 2 is negative 4, 3 times negative 2 is negative 6. So A is at 2, 3 on this picture. So negative 2, a factor negative 2 puts you at negative 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Negative 4, negative 6 is actually down here. Okay, so a dilation by a negative constant is a combination of a regular dilation, or a normal dilation, of a factor of 3. It's still 3 times the distance away. But notice when we did the positive one, it went out this way. But this is actually going to be, the negative makes it also a combination of reflection and the origin. So instead of being 3 times to this side of the origin, we're 3 times the opposite side. So this is a reflection through the origin. In the origin, so it goes the opposite direction. So the negative just makes it go in the opposite direction. The factor is still the same. So you can see the important part about a dilation is you multiply the coordinates by the same factor. If it's a positive or a negative whole number or integer, it will be an enlargement and farther away from the origin. And if it's a fraction, it will be smaller and it will be closer to the origin.